Hello friends, welcome to Learner's Planet. Friends, our fifth session for basic problems on circles. Already we have done 4 problems, basic problems session on circles and 2 basic terminology or concept related session on circles. Now I am confident that you will be gaining confidence in this topic. If you are able to do these problems and if you are doing all these problems with me, then you must be gaining the confidence. Let's have some more problems in this session, and once again just see the problem when it appears on the screen. Pause the session, try to do it on your own, right? So let's begin. Now try this problem. In the figure, O is the center of the semicircle ABCD. O is the center of the circle, okay. Angle COD is 42 degree, then X is equal to, okay. See here, from this segment or from this arc, this angle is at the center, and from the same arc, this angle is at the circumference of the circle. So if it is 42, it has to be 21. First thing. Then this BC is parallel to AD, right? So this we can see the shape of Z. So these two are alternate angles, and alternate angles are equal, right? So if it is 42, it has to be 42, right? Now this is exterior angle for this triangle BPC. So this exterior angle will be equal to sum of interior opposite angles, right? So X is equal to 21 plus 42, that is 63. Simple. Now this problem. In the figure, O is the center of the circle, AOB is straight line, and BCD is the tangent to the circle at C. Find X. See here, you can see chord AC and tangent BCD, right? Wherever you see an angle between chord and tangent, just try to recall alternate segment concept, right? That means the angles in alternate segments are equal, right? So I just match this point, or just drawing this chord. Now if this angle is X, it has to be X, as angles in alternate segments are equal, right? Now I suppose this point is P. AP is diameter of the circle, since it is passing through a center of the circle. So AP is diameter of the circle. So angle in semicircle is 90 degree. So that means this angle is 90 degree, right? Now we see triangle BCP. Okay. Now this portion is what? 90 minus X. This is 90, this is X, so this is 90 minus X. Plus this portion is 180 minus X. This is X. This total is a straight line, so it is 180. So only this portion is 180 minus X. Plus this 28 degree. And these three are angles of triangle CPB. So it has to be, sum has to be 180. Okay. So 2X is equal to 90 plus 28. So X is equal to 45 plus 14, 59. Simple. Now see this question. In the figure, AEC is a diameter and DEB is a straight line. Find X. Okay. AEB is diameter. That means this angle must be 90 degree. That is angle in semicircle. Now out of this, this is 47. That means this must be 43. Okay. Next is in this arc AB, angle ADB is there and angle ACB is there, right? On the same segment, both the angles should be equal. So if it is 63, it has to be 63, right? Now in triangle ECB, it is 43, it is 63. X plus 43 plus 63 should be 180. Okay? So X is equal to 180 minus 106, so it is 74. Right? in the figure, AB, BC, CD are in the ratio arc AB, BC, CD 2:1:3. Find angle ADC. This angle we have to find out. So first of all, I just draw the center of the circle and make radius. This angle DCB is given to us as 96 degree over here. So precisely this is the figure. Okay, now this is the center of the circle. Now since a ratio of arc is 2:1:3, that means the center angle will also be in the same ratio, right? I assume BC to be x, then this must be 2x and CD must be 3x, right? I assume this angle to be y, this small portion to be y. Now OC is equal to OD, so in triangle ODC, the OD is equal to OC, then this is y, then this will also be y. This small portion will also be y, right? So 3x plus y, precisely 3x plus 2y is equal to 180. Okay, in this triangle ODC, 3x plus 2y is 180. Similarly, in triangle OBC, this angle is 96 minus x, 96 minus y. See, this complete angle is 96, so only this portion is 96 minus y. So if it is 96 minus y, it has to be 96 minus y, because OB and OC, both of them are radius of the circle. So 96 x plus 96 minus y plus 96 minus y is also 180, right? So we got two equations in x and y. So 3x plus 2y is 180. Here x minus 2y is equal to minus 12, right? So 2y is cancelled. 4x is equal to 168. So 4x is equal to 168. Okay, how much we want? We want this angle, that is angle ADC, that is we want this complete angle, not y but the complete angle, right? Now from the arc ABC, this is the angle on the center, and this from the same arc, this is angle on the circumference, right? So this will be half of this. So this total is 3x, so it has to be 3x by 2, right? So what we want? 3x by 2. So 4x is this, so 2x will be 84, and in fact x will be 42, right? 4x is this, so 42, and that's x, and into 3 by 2, so it is 63. Okay, so we got two equations, and after making two equations, it's very easy to solve. See this, in the figure AB is tangent to the circle at B, find angle DCE. DCE, this angle we have to find out. Okay, this angle is given to us as 110 degree, and DC parallel to AR, it is given. Okay, this is the angle between this chord and tangent, right? So we can use alternate segment theorem. What I do is I just join B and C. Okay, see this complete is 110, so this must be 70 degree, right? So if this is 70 degree, it has to be 70 degree. Reason, alternate angles in alternate segments are equal, right? And this is parallel to this, it's given. So this angle will be equal to this angle, shape of Z. So this angle will be equal to this angle, alternate angles are equal. So if it is 70, it has to be 70. If this is 70, this is 70, total is 140. So this portion must be 40, right? If this portion is 40, this is 70, this is 40, 110, that means the remaining portion. Okay, let's see what happens. Now this is 70, this is 110, because CEB is a BD cyclic quadrilateral, so opposite angle should be 110. So if it is 70, it has to be 110. Now EC is equal to EB. That means this angle and this angle should be equal, right? So it is 110. So we are left with 70. 70. So this must be 35. This must be 35, right? Now DCE is 35 plus 70. That is 105. Okay, pretty simple. I hope you are clear, though we don't need this 40, but it's okay. Now in the figure, CAB is a semicircle and ABCD is a parallelogram. Find the area of ABCD. Okay, first of all, what we do, see BC is diameter. So first of all, I join point A and C. So now this is 90 degree. Angle in semicircle is 90 degree. So this is 90 degree. Now ABC is a right angle triangle, right? This angle is 90 degree. So 5, 13. So AC perpendicular of this triangle ABC must be 12, right? We have 5, 12 and 13 Pythagorean triplets. So this is 12, right? And this AC is apart from perpendicular of this triangle, it is also diagonal of the parallelogram. Now diagonal of the parallelogram divides the parallelogram into two equal triangles, right? Area of ABC will be equal to area of ADC. So what we can do, we can find out the area of triangle ABC, and when we'll double it, we'll be able to get the area of the parallelogram, right? Now how do we find out the area of the triangle ABC? That is, this is the base, this is the altitude, right? Altitude, or we can say base into perpendicular into half. So base is 5, perpendicular is 12, so half of them will be 30, and double of 30 is 60. That is the area of parallelogram. So you see, hardly any paperwork is required. The simple concept we have used, angle in semicircle is 90 degree. After that we calculated the area of this triangle, and double of this triangle's area will be area of parallelogram. Okay. Here O is the center of the circle and we have to find out the value of X. Okay. So first of all, what I do is I join O and C. Okay. Now OC and OD, both of them are radius. OD and OC, both of them are radius. So this angle is X, that means this angle will also be X, right? Next is, this is in triangle ECB. Triangle ECB. This is 20 degree. This is 114 degree. So this must be 180 minus 20 minus 114. So it is 46 degree. So if it is 46 degree, OB is equal to OC. So this is 46 degree, that means this portion should also be of 46 degree. And this complete is 114. So if this is 46, the remaining portion will be this 114 minus 46. And that is actually X. So that is 68. Okay. OC is equal to OD. This is X, that is 68. So this will also be of 68 degree. Pretty simple. Very simple problem. In the figure, AT is a tangent to the circle at T and ABC is a straight line. Find AT. Okay, we'll be using tangent second theorem. So AT square is equal to AB into AC. Right? AB is 9. AC is 9 plus 16, that is 25. That is 80 square. So 80 will be 3 into 5, 15. The problem can be solved in seconds if you know tangent second theorem, right? Too many times I have explained this tangent second theorem. In the figure, AB is the diameter of the circle, find X. Pretty simple problem, friends. AB is the diameter of the circle, that means this angle is 90 degree, this angle is 90 degree. BC is already given as equal to AD, and AB is the common base between the triangle ADB and ACB, right? That means triangle ADB is congruent to triangle ACB. Right? If both the triangles are congruent to each other, then their corresponding angles will be equal. So if this angle is 26 in triangle CAB, this angle will also be of 26. Okay. Now if we see triangle triangle ABC, 26 plus 26 plus X plus 90 is equal to 180. That means 26 plus X must be 90. So X is equal to 90 minus 52. So that's 38. Okay. So simple concept we have used over here. If two triangles are congruent to each other, their corresponding angles are equal, right? In the figure, AD is the diameter of the circle. If arc BC, arc CD, ratio 3:5:7, then triangle, angle ADC, not triangle, but angle ADC, we have to find out, right? Now, arc length are in the ratio of 3:5:7. That means this arc will make angle at the center in the same ratio, that is 3:5:7. So what I do is I join all the points to center of the circle. Now AB is 3-part. So AB, that means this angle must be 3x. This angle BC is 5-part, so this angle must be 5x, and AB CD is 7x, so this angle must be 7x. Now since AD is a diameter, it has to be a straight line. That means 7x plus 5x plus 3x, that is 15x, must be 180, right? So 15x is 180, so x is equal to 14. I'm sorry, 12. Okay, so now we have to find out angle D. So this is 7x, so this must be 84. This is center. Now OC is equal to OD, right? So if this is 84, remaining 96 will be distributed equally among this angle and this angle, between, I'm sorry, this and this. So 96 divided by 2, that is 48 degree. You got my point? 7x, x is equal to 12 because it is 7x, 5x, 3x. The funda is the arc ratio, length of the arc is in the ratio 3:5:7. The same will be ratio at the center. So it is 3x, 5x, 7x. The total is 180 degree because AD is a straight line. So x is equal to 12. So 7x is equal to 84. Right? Now angle D is equal to, or I can say just angle 1 and angle 2. So angle 1 is equal to angle 2, and angle 1 plus angle 2 is equal to 180 minus 84. So we can say it is 96. Now angle 1 and angle 2, both of them are same. So each one of will be of 48 degree. Okay, so that's pretty simple. Now on the very same concept, this one more problem we have. In the figure, arc AB, arc BC, CD and DA are given. Find angle BCD. So first of all, since arc lengths are given, we can find out the ratio of the angle at the center. I suppose this to be center, then this I just join all the points. Okay, now as I've already told you, arc length, then the ratio of angle at the center will be in the same ratio. So this must be 2x, this must be 3x, this must be 4x, and this must be 6x, right? Now 6 and 4 10 and 3 13 and 2 15x, and the complete center angle is of 360 degree, right? So x is equal to 15 2s are and 4s are, so x is equal to 24, right? Now we have to find out angle BCD. Angle BCD, that means this complete angle, right? Now if this angle is 3x, that means this complete angle is 72 degree, right? This angle is 72 degree, and OB and OC, both of them are radii. So 108 will be distributed between this angle and this angle equally, right? So this portion is 54 degree, right? Similarly, this angle is 4x, so the total will be 96. So this plus this must be 84. So this plus this is 84, so this will be half of 84 because OC is equal to OD. So half of 84 is 42. So this portion is 54, this portion is 42. So this complete is 4 and 2 6 and 5 and 4 9, 96 degree, right? This complete angle is 96 degree. Okay, so that was very interesting. I hope you are getting my point. In the figure, O is the center of the circle, find x. Now that's pretty simple. You don't need even paperwork to solve this problem, right? Now what is the concept that we are going to use over here? See, O is the center of the circle, so OB and OA, both of them will be radius. So if this angle is 35 degree, this angle should also be of 35 degree, right? So the center angle must be in triangle OBA, this is 35, this is 35, so it has to be 110, right? The three angles should be 180 degree, 35, 35, 110, right? Now from the same segment, this is angle at the center and this is angle at the circumference, right? So this angle should be double of this angle. So if it is 110, it has to be 55 degree. So hardly paperwork is required, and a very simple question if you know this concept. Okay, and very frequently asked, this sort of questions or this pattern of questions are very frequently asked in competitive exams, right? So if you know the concept, you just can do the problem in just 20 seconds. Okay, so x must be 55 degree. Now this question, in the figure, O is the center of the circle ABCD. If EAB and EDOC are straight lines, EA is equal to AO, then find AEO. Okay, so first of all, we see this line AD. From this segment, this is angle at the center and angle at the circumference, and this is angle at the center. So this angle should be double of this. So if it is x, it has to be 2x, right? Now EA is equal to AO, AO is equal to EA. So if this angle is 2x, it has to be 2x, right? Now see this triangle BED. The exterior angle is 36 degree, and exterior angle should be equal to the sum of remote interior angles, right? So 2x plus x, that is 3x, is 36 degree. That means x is equal to 12. We have to find out 2x, so that is 24 degree. So this is 24 degree. Very simple, same concept we have used. See, diagrammatic different diagrams are possible for the same concept, that angle at the center is double than that of the angle at the any other part of the circle. So various diagrams are there. We have discussed so many diagrams, right? But ultimately, if you know the concept, you'll be able to crack the problem very easily, right? When you see on the same segment the angle at the center and angle at the circumference, yes, you should be able to recall this concept, right? Once you are able to recall this concept, it's a matter of seconds to solve the problem. So your answer is 24 in this case. So very basic properties of triangle and very basic property of circle we have used over here. Now this problem, in the figure, XAB, XDC are straight line, DX is equal to 5, AX, AB, all of them are given. You have to find out CD now. Very simple concept. Two chords AB and CD are extended and they are meeting at X, right? So product of their segments will be equal. The concept we have already discussed in basic session. So precisely XA into XB is equal to XD into XC. I assume DC to be x, maybe p. Okay, so 6 into 10 is equal to 5 into 5 plus p. Okay, so 5 plus p is 12, that means p is equal to 7, that means CD is equal to 7. So if you know this concept that if the chords are extended and they meet at any point outside the circle, then product of the segments will be equal, right? Whether they meet internally like this, we have already discussed the problems, then OA into OB will be equal to OC into OD. The same concept, if they are meeting outside the circle, then also XA into XB is equal to XD into XC. Product of their segments will be equal. Okay. In the figure, ABC is a semicircle with BC is equal to 7, arc BC is 7, and angle ACB is 55 degree. Find arc AB. That means we have to find out this length. To be able to find out this length, we have to find out an angle. First of all, what I do is I just complete the diagram. I suppose this is the center of the circle. So see, if we know this angle, it will be easy for us to find the length of this arc. Okay, and the second thing what I do is I just join A and B, right? Now, and I assume the center of the circle to be O. Okay, now CBA, AC is diameter, that means this angle must be 90 degree. If it is 90 degree, it is 55 degree, then this must be 90 minus 55, that is 35 degree. Okay, now next concept, OA is equal to OB. Both of them are radius of the circle. So if it is 35, it has to be 35, right? So 35 and 35, 70 degree. That means this angle must be 110 degree and this angle must be 70 degree, right? Now this arc, the center angle, the angle over here is 70 degree and the arc length is 7, right? So we can use the formula theta by 360, that is theta by 360 into 2 pi r gives the length of the arc, right? This is arc length formula. We have discussed this so many times. Here theta is 70 degree. So 70 by 360 into 2 pi r is equal to 7, right? So r is equal to, or we can say 2 pi r is equal to 36, right? Now we have to find out the length of arc AB. That will be 110 by 360 into 2 pi r, right? 110, the center angle is 110 out of total 360 into 2 pi r. So 2 pi r is 36. So it is 36, 10, so it's 11, right? So arc length AB is 11. Very interesting problem, very conceptual problem. I just go for a quick recap. First of all, we join point A and B. AC is diameter, so angle CBA will be 90 degree, being angle in semicircle. So in triangle CBA, if this angle is 90 degree, this is 55 degree, so the remaining part will be 35 degree. That is this angle, right? So the sum of the three angles should be 180 degree. So if this is 35, in triangle OBA, OA will be equal to OB. Both of them are radii of the circle. So if this is 35, it has to be this portion only this portion. Be very clear about it. This entire is 90, but only this portion will be 35 degree, right? So in triangle OBA, this is 35, this is 35, that means the remaining part is 110. Now if it is 110, being linear pair, this will be 70 degree, right? So angle at the center is 70 degree made by this arc BC. Okay, so if this angle is 70 degree, we can calculate the length of this arc BC, right? So length of this arc BC is given to you. So unknown quantity r can be calculated. We calculated the value of 2 pi r because we require 2 pi r only. Okay, so 2 pi r is 36. The figure shows a circle with diameter AD. If AB is equal to BC is equal to CD, find x plus y plus z. Okay, a diameter AD. So first of all, I just join A and D to make diameter AD. Now, next is see, we don't know this angle C, right? We have to find out x plus y plus z, but we don't know angle C. So what I do is I just draw radius of this circle. Okay. Now we have already learned that equal chords make equal angle at the center. Now AB is equal to BC is equal to CD. That means all of them will make the same angle at the center, right? Suppose this is A, then this will also be A, this will also be A, right? So the total angle at the center is 3, and precisely AD is diameter. That means 3A is equal to 180 degree. That means A is equal to 60 degree. Now OD is equal to OC. Both of them are radius of the circle. So this angle will be equal to this angle, right? If this is 60, it has to be 60, it has to be 60. Similarly, this angle will be equal to this angle. So if it is 60, it is 60, both of them should be 60. So the entire angle C will be 120 degree. Right? Now I just write down, and this angle, that is angle in semicircle, so it will be of 90 degree, right? AD is a diameter, so this is 90 degree. Now I write down the equation x plus y plus this angle, that is 120 degree, plus z, this angle, plus 90 degree, right? 1, 2, 3, 4, 5. All these are angles of pentagon, and sum of angles of a pentagon is 540 degree. Right? So only x plus y plus z we have to find out. So 540 minus 90, that is 450, 450 minus 120, 330 degree. Right? So very simple concept. We have used equal chords make equal angle at the center. So 3A, A and A. 3A is 180 degree because AD is diameter. So 3A is 180, A is 60, and similarly these two angles, and from that we can calculate angle C. Angle C we know, then sum of the angles of the pentagon is 540. X plus y plus z can be calculated easily, right? Once again, too many questions on the topic circles we have done in this session. Do revise this session and the previous ones. I'll see you in the next session once again. Bye bye.